So in the previous video, we have seen how to do the Gaussian eliminations, and then we have seen how the reduced row echelon forms looks like. Okay, so just a recap what we have learned in the previous video. So in order to get a ref forms, so the matrix must have the following properties. There is 4 properties here, so you can see the first property is that one. So you can read that, the second property, the third property, and the fourth property. Okay, so we have discussed this in the previous video, so you can check back in the previous video. So this is the examples of matrix in the ref form. So you can see that this is some of the examples of ref matrix. Next, we look at row echelon form. Okay, so a matrix that has the 3 properties of ref. Okay, so you can see that if a matrix that have 3 properties means we have 1, 2, and 3 only, so the fourth properties is not being met. So that means that the matrix that you got is in the forms of row echelon forms. Okay, so this is the example of the matrix in row echelon forms. So next, consider you have these examples of matrices where you have a matrix A, B, and C. If you try to solve the matrix, the solution for the matrix can come in 3 different solutions. The matrix can be inconsistent, or it can be have many solutions, and it can have only one single solution or unique solutions. Okay, so let's look at the example. We start with example 1 first. So let's say this is our column X, our column Y, Z, and this is our answers. So we can write this in a linear form. So it will look like this when you write in a linear form. So if you simplify the equations, you have x equal to 0, y plus 2z equal to 0, 0x plus 0y plus 0z equal to 1. So that's fine. This is fine. But if you look at these third equations, you have something which is 0 on your left-hand side equal to 1 on your right-hand side. Since your answer is 1, so you cannot have your questions to become like 0. Okay, so because of that, we cannot put any values of x, y, or z. So we can say that this system is inconsistent because we have an answer, but we don't have a questions that we can put to produce the answer that we want. So this system is inconsistent. So next we look at matrix B. We put matrix B in a form of linear equations. Again, this is our x, y, z, and that is our answer. So we have x plus 0y plus 3z equal to negative 1. 0 plus 1y minus 4z equal to 2. And we have 0x plus 0y plus 0z equal to 0. So that one's we can write x plus 3z equal to 1. Negative 1. And for the second equations, y minus 4z equal to 2. So the third equation is fine because we got 0 equal to 0. So we just leave it that. So based on these 2 equations, we can, let's say this is our equation 1. So from 1, we can get x equal to negative 1 minus 3z. And from 2, we can get y equal to 2 plus 4z. So you can see here, in order for you to get x, you need to have a value of z. And in order for you to get y, you need to have a value of z as well. So the value of z will give you 2 different values, which is x and y. So in this case, z can be set as a free variables. That means z can take any value, and if z takes, for instance, 0, we have x will be equal to -1 and y will be equal to, so you can see here we have multiples values or multiple solutions which come from x and y. So because of that, we can say that this system has many solutions. So the solutions come from the value of x and y. Finally, we go for the examples on matrix C. Again, the first columns we can put it as x, followed by y, z, and the columns where we got the answers. So if we put that into a linear form or linear equation form, we get x minus 5y plus z equal to 4. Okay, so the rest of the equation is 0, so we don't need to write it. So based on this equation alone, we can summarize that we need a specific value of x, y, and z in order to produce a result of 4. So because of that, we can say that this system has a unique solution or one single solution. All right, so next we move to example 2. So in these examples, we need to solve the following system of linear equations. So we're going to use a Gaussian elimination method, but before that, we need to put this into a matrix form. So if we put into a matrix forms, we will get these equations or this matrix. So the first columns will indicate your x. The second column is y, z, and w. So the last column will be the answers of the linear equations. Okay, so when we try to solve this, what we actually do is we want to find the values of x, y, z, and w. So there's two ways how we can solve these ones. Either we want to convert this into an identity matrix where the last column is the answers for your questions or for your parameters x, y, z, and w. So that's the first approach. Or the second approach, what we can do is we convert this into a where you have a reduced echelon forms. So from that matrix, then you can put it back into a linear forms and then solve it. Okay, so let's start with this method 2. Okay, and then we will see how we can solve or how to get x, y, z, and w using method 2. All right, so that row is our row 1. We have row 2, row 3, and row 4. Okay, so for the first steps, we can start from this coefficients. We have a 0 in here. Okay, so supposedly we need to convert into some numbers. So we can use a swap techniques where we take from other rows, we put it in that row. Okay, so let's say we swap row 1 with row 3. So we have, and then we swap row 2 with row 1. So we have, and we swap row 3 with row 2. So we have, and finally we just write back row 4. We have, so the next steps, we move to the second coefficient. So we got 0 here. So that's fine because that should be 0. So we move to another coefficient, which is -4. Okay, so we need to change -4 to become 0. So to do that, we take row 3 plus with row 1, but we need to multiply row 1 with 4. So that will give us 0. So next, we look at our next coefficient 2. So we need to change to become 0. So we can take row 4 plus with row 1, but you need to multiply row 1 with -2. So that will give you 0, 3, and for the rest of row 1 and row 2, you can just write it back because you didn't do any operation on them. Alright, so next we got 0, that's fine, so we move to another column. So -1 is fine, it's numbers, we don't need to convert. And then that's fine. So we need to convert 3 to become 0. We take row 4 plus with row 2, but we need to multiply row 2 with -3. Okay, so that will give us okay, so the rest of the row, we just write it back because we didn't do anything on it. Okay, so next we move to coefficients. 3 is fine, 7 is fine, 13 is fine, so we move to -27. So we need to change -27 to become 1. To do that, we take row 4, we add with row 3, but we need to multiply row 3 with 2. So that one will give us so the rest of the rows, we can just write it back. And then in the next steps, I will move this row 4 into row 3. So I can have this 1, 1, and another one line up together. So it will look like this. So you have that this 2 row, okay? I swap row 3 with row 4 and row 4 with row 3. So the rest of the row, we just write it back. So you can see that flow. So finally, I need to convert 3 to become 0. So I take row 4 plus with row 3, but I need to multiply with 13. So that will give us and for the row 3, you have -1, so you want to change it to become +1, so you multiply with -1. So row 3 will become, and for the row 1 and 2, you just write it back. So we have this matrix. So you have a ref forms, okay? So based on these forms, we can change this into a linear equations by assuming that our first column is x, our second column is y, Our third column is Z, and our fourth column is W, and that is our answer. Okay, so if you do that, you change it into a linear system or linear equations, you have these equations. Okay, so you have four linear equations. So you can solve this, and finally, if you solve it, your x is equal to 6, your y equal to 1, and your z equal to 2, and your w is equal to -10. All right? Okay, next we look at example 3. We have this system of linear equation, but this is already in matrix form. So we need to solve it to becomes either RREF or REF. Okay, so first we look at the coefficients on our first column. So we have a 0 in here. So we need to have some numbers here. Okay, so if we refer to REF or RREF forms, we need to have some numbers here. So what we can do is we swap our row. So let's say this is row 1, row 2, and then row 3. Okay, so row 1, we swap with row 2. So we have and row 2, we swap with row 1, we have and row 3, we just write it back, and we have, so we have this form. So the next stage, we need to change 2 to become 1. So what can we do is we multiply row 1 with half. So we have these equations. So for the row 2 and row 3, we didn't do anything. So we just write back. Okay, so next we move down. Okay, so let's say we want to convert that to become 0. Okay, so to convert that become 0, we take row 3 plus with row 1, but we need to multiply row 1 with -2. Then if you add it, it will give you these equations. So for the row 1, as for the row 1 and row 2, you didn't do any operations, so you just write it back. So you have this form. So next we move to another coefficients. We check 2 is fine, 0 is fine, 0 is fine, and we move to another columns. -5 might be fine, and this is -2, but here you got 0 and you got 0, so most probably that one will not give you 0. So let's say we change that one to become 1. So to convert -2 to become 1, we take row 2, we plus with, we multiply with -1/2. So that will give us these numbers. And for the row 1, we don't do anything, so we just write back, as well as for the row 3. Okay, so the next coefficients that we can change is we stop here just now, so we move to here. So next we move to coefficient 5. Okay, so since we have 0 here, okay, and then you got 0 here, you got 1 there, so 5 we should be able to change it into 0. So to do that, we take row 3 plus with row 2, but we need to multiply row 2 with 5, negative 5. So that one will give us the equations, and for the row 1 and row 2, you just write it back. Okay, so next we look at another coefficients. Okay, so 3 is all right, 0, 0, 6, negative 7 over 2. That's probably okay. And that one's maybe we can change it to 1, since I don't think we can change it to 0. So to do that, we take row 3, we multiply with 2. So that will change it into 1 to become like this. Okay, so next, maybe we can simplify that one, negative 7 over 2. Okay, so I think we can change it into 0 based on this equation here. So let's say we want to change it into 0. So we take our current R3. Okay, so this is our current R3. We multiply with 7 over 2 multiply with R3. Okay, so that is our current R3. So we plus with the previous R2, which is that one. Okay, so this will give you these equations. Okay, so it might be a bit confused. You can do step by step. So in these steps, I combined two different arithmetics into one matrix. Okay, so you can split it into two different matrices. So you might not get confused. So for the row 1, we didn't change anything, so we just write back. So we have this matrix. Okay, so next, is there any more coefficient that we can change? Okay, so maybe we can change that. Okay, so can we change it to become 0? Yes, because we have that one. So to change 6 becomes 0 in row 1, we take row 1, we plus with row 3. Okay, that's our row 3, but we need to multiply with negative 6. So if you do that, you get these numbers. Okay, so for the row 2 and 3, you can just write it back because we didn't change anything. So next, so maybe you can change that into 0 because you have that one. Okay, so to do that, okay, we take row 1, we plus with row 2, but row 2 we need to multiply by 5. Okay, so to make it become 0. So we have these forms, and for the row 1 and row 2, sorry, for the row 2 and row 3, we didn't change anything, so we just write back. Okay, so we have that form. So this should be in the form of R, R, E, F. Okay, so you can check this. Okay, so once we got these ref forms, okay, so let's say this is our column x1, x2, x3, x4, x5, and this is the answers. Okay, so we have x1 plus 2x2 plus 3x4 equal to 7. That's our first equation. So our second equation, we have x3 equals to 1. And our third equation, we have x5 equal to 2. So that would be our solutions, where we have a specific solution for x3 and x5. Okay, so you can see in here, based on these solutions, your value of x1, x2, and x4, they must have a specific value to get it to become 7. Okay, so because of that, we can set this system as a unique solutions. Okay, so now we move to example 4. So in this example, you need to solve the following system of linear equations where we have 3 different equations and we have 5 different unknown variables. So first we need to put it into a matrix form. So if you put it into a matrix forms, you will have this form. So with this form, we want to change into ref or RRAF. So we identify that is our row 1, this is our row 2, and that is our row 3. Okay, so firstly, we look at our first coefficients from the first columns. We have 1. Okay, so that's fine. And we move to the second coefficient 2. So we can change this to become 0. So to do that, we take R2 plus with row 1, but you need to multiply row 1 with negative 2. So if you add with row 2, you will get so next we can change 5, okay, coefficient 5 to become 0 as well. So to do that, we take row 3, add with row 1, but we need to multiply row 1 with negative 5. So that will give us these equations. So for row 1, we just write back because we didn't perform any operations. So we have this form. So next we move to the next coefficient. 2 is all right, 0 and 0 is all right, negative 3. So usually for the row 1, we will try to solve it at the last steps. So we have 1 and 2. Okay, so most probably we can start with 2 first. So we change 2 to become 0. So to do that, we take row 3. We add row 3 with row 2, but we need to multiply row 2 with negative 2 before we can add into row 3. So that will give us these 0 equations. So for the row 1 and row 2, we didn't do any operations, so we just write back. Okay, so once we reach to this point, so okay, so I think this is already in ref form. So the next step, we convert back into linear equations, and it will become like So we have two equations. So from equation 1, we can write such as x1 equal to these equations, where our x3 is equal to these equations. So if you put x3 back into x1, so from x1 we can further simplify to become these equations. So what that tells you, your solutions for x1 and x3 depends on x2, x4, and x5. So they are called as a free variables. Okay, so these free variables can take any value. So once it takes values, so you will have various solutions for your x1 and x3. So in that case, we can say that this system has many solutions.